I think if you're taking more than 5 supplements, it's probably counterproductive. Certainly 10.
We are here at RadFest, joined by Dr. Matt Kaeberlein, one of the top minds in longevity. So I want to begin the interview by asking you, what are you working on that you're most passionate about right now?
Yeah, so maybe just for a little bit of background, I spent the first 25 years of my career doing basic science, studying the genetics of longevity, trying to identify genes, interventions that can slow aging across the animal kingdom, with the goal of slowing aging in humans. And so one of the projects that I developed is something called the Dog Aging Project, which is a large-scale study to understand and intervene in the aging process in pet dogs living with their owners. So that's one of the most fun things that I've done in my scientific career. I'm a dog person, so so obviously, part of this is about helping companion animals live longer, healthier lives, but also what we're going to learn about aging in humans. And then my day job now, I left my academic position about 2.5 years ago, and I run a company called OptiSpan, which is really about taking what we've learned from the research and applying it in the clinical setting in humans. So I would characterize this as a healthcare technology company first and foremost. But we also run clinical programs. So we have 2 clinical programs right now. We're seeing patients, but our goal is really to create a platform that enables healthspan medicine for as many people as possible. And one of the core principles of that is it's got to be scalable, meaning it's not for billionaires.
Okay.
And it's got to be evidence-based. So we are very strong in our belief that science really has to be the foundation if this field is going to be successful.
Do you see a lot of non-evidence-based work right now?
Absolutely. I mean, so there's a couple of things I would say about that. There are things where there's zero data to support it. And I think,
like what?
I don't want to lump all supplements together because that's not fair. There's a lot in the supplement space that is not data backed. And yet you have people selling these as longevity supplements.
Okay. Could you delve into that? Be a little specific on what you mean by that?
Sure. So there are a couple of categories that I would say that of supplements that fall under that umbrella. One are supplements where there was some data, but then it turned out not to be reproducible. So resveratrol is a great example of that. Okay. Resveratrol is the most debunked longevity molecule in history.
Really?
There have been dozens of studies published, and the meta-analysis of all those studies is there is a 0% effect on lifespan in laboratory animals. And yet you will still find plenty of people selling resveratrol as a longevity supplement out there. Okay. There are also lots of supplements that people market as longevity where there just is no longevity data. It just doesn't exist.
Okay.
So that I would put in the non-evidence backed group. And there are other experimental procedures, but then I would also say there's a lot of stuff in the gray area. So if you walk through the exhibitor room here, there are lots of examples there of things that might have an impact on longevity. And those are important to study. I would put exosomes, stem cells, therapeutic plasma exchange, even some of the gene therapies, which I am concerned about, I would say might have a positive impact on health span or lifespan in people. The problem is we don't know. And what concerns me is when you have people who have credentials, letters after their names, who get up on stage and speak with confidence as though these things definitely have benefits and everybody should be doing it. That's, I think, misleads a lot of people. So that's one of my concerns about the field right now is there is a lot of gray area and there are too many people talking with confidence and in terms of certainty where we just don't know. There's a lot of uncertainty.
So confidence, but not based or backed by evidence.
Yeah, I think we have to get comfortable with the fact that there is uncertainty and with probabilistic thinking around these things. Right now, for example, there's really been maybe one clinical trial of therapeutic plasma exchange of any reasonable size. And it looked promising, but really no strong evidence that it slows aging in people, right?
So what do? You know, people take a lot of supplements. My cupboard is full with supplements and interesting in new therapies and stuff.
Uh-huh.
So like, what can you do?
Well, so I think obviously it's an individual decision. I would say the general my general advice would be careful who you listen to. And again, it's hard to know who's credible and who's not. Again, there I think one warning sign is if somebody is speaking in terms of 100% certainty that you should do X, be skeptical, especially if they're trying to sell you something.
Okay.
Doesn't mean they're wrong, doesn't mean they're dishonest, but it's a pretty good indication that they might be. So the other thing I would say is, and this is where I think you just have to kind of land, you have to figure out where you land. I think, and this, I'm just pulling this number out. There's nothing special about this number. I think if you're taking more than 5 supplements, it's probably counterproductive. Certainly 10.
Okay.
And there's a few reasons to believe that could be the case. We know in laboratory animals, when you start combining things that extend lifespan, more often than not, they cancel each other out. That's just a fact. We also know the human body is one of the most complex pieces of machinery out there. And if you just think about any piece of machinery you could imagine, and if you open the door and go in there and start moving wires around, what's the likelihood you're going to make things better versus make things worse?
Very
right?
small.
So that's kind of what you're doing if you're taking 20 different supplements. The interactions are unpredictable. It's not the case that just because one supplement by itself could be beneficial and the other supplement could be beneficial, when you combine them, you're going to get an additive effect. So I think people they don't think about it that way, but it's a useful way to think about it.
So, okay. What would you suggest for people on the edge of taking supplements?
Well, here's what I can tell you.
20?
Yeah, here's what I do for myself, right? So take it for what it's worth. So one thing is you can measure some things, right? So there are some molecules in our bodies that we can measure. You should. We do comprehensive blood work and other biomarker assessments at OptiSpan. That's my company. And some of them we know what the optimal range is. So like vitamin D, omega-3 are really easy, obvious examples. We have good blood tests for those. We know more or less what the optimal range is. If you are outside that optimal range, you can and probably should supplement to get into the optimal range. That's one class. There aren't a lot of things in that class, but that's one class. If you can measure it, supplement to your optimal range. And then I personally don't right now take any other non-pharmaceutical supplements besides creatine. I think creatine's solid. Lots of long-term data in people for body composition, and we're getting some data now for other benefits of creatine. And then you can look at the pharmaceutical side. There, if you have a disease, take your medicine, right? But if you're thinking about preventative use of pharmaceuticals, I think there are some that are intriguing and right for some people. I would put rapamycin in that group. I would put metformin in that group, although I personally am not a believer in metformin for non-diabetics. I think there are better drugs for metabolic health than metformin that also have a longevity benefit in laboratory animals. SGLT2 inhibitors are an example. That would be canagliflozin and pagliflozin. I think GLP-1s are really interesting, especially if you are overweight or you are pre-diabetic. I think PDE5 inhibitors, so Viagra, Cialis are interesting and probably improve circulation. So I think there are a small number of those that, depending on the individual, you might want to consider. So I personally, right now, am taking rapamycin and an SGLT2 inhibitor. But again, I think it's important to recognize I'm doing that with an understanding of the research and understanding of the risks, and I'm doing a hopefully rational risk-reward analysis.
And how are you measuring the results, the effect on your body?
So it's hard with rapamycin because we don't have great biomarkers, and again, I'm not personally convinced that any of the quote-unquote biological age tests that are consumer grade work. In fact, I would say the opposite. I am convinced they don't work, and I have the data to prove it.
What's the data?
So I did an experiment where I got 4 different consumer epigenetic age tests from 4 different companies. I did them in duplicate from the same day, same biological sample. The standard deviation was 7.5 years. It told me I was somewhere between 40 and 64.
Really?
Not useful. So
wow.
So those tests, I mean, again, so here's what I would say. The consumer grade tests, they are not regulated. There's no independent body that looks at the results. We don't have any information on quality control. We don't have any information on precision or accuracy, and they're not actionable. So I don't see them as useful tools at this point. I think we have way better biomarkers that we can use that actually tell us something about health. So that's what I would look at. So anyways, this is sort of a long answer. So for rapamycin, we don't have great biomarkers to know if rapamycin is working. For people who have high levels of chronic inflammation and have either, say, chronic pain or chronic fatigue, there we often see that people start taking rapamycin and feel better. Okay, so it's not as quantitative a biomarker as I would like, but that's the goal, is to make people feel better and be healthier, right? So that's a good thing. The SGLT2 inhibitors, I would say there we have really good biomarkers. You can put a continuous glucose monitor on and see your glucose levels come down.
Okay.
So I think it just depends on the intervention, how easy it is to assess efficacy.
Okay. And so back to the your biological age. So you said there was a 7-year standard deviation from 45 to 65?
So when I did the test, I was 53 and a half. The mean of the 8 results came back as like 53.8. So very close.
Mm-hmm.
But the standard deviation, was 7.5. And the range was 40 to 60 something.
Wow.
Yeah.
Okay. So what can someone do? Are there
So here's what I'd say.
valid tests for this?
Don't waste $500 on an epigenetic age test, would be my advice. Get
So what should you
comprehensive
measure?
get comprehensive blood work. That should include, in my view, a deep dive on hormones. I mean, it depends a little bit on your age, but if you're over 40, let's say, a deep dive on hormones. The standard sort of blood work you would get from your annual physical, plus insulin, more detailed look at lipids, vitamins. We talked about vitamin D, omega-3, toxins, so mercury, lead. So that all is going to be in the comprehensive blood work. And then you're going to want to get physiological assessments. So I like VO2 max. I like strength, flexibility, body composition, really important. So DEXA is a fantastic tool for assessing body composition.
Okay. And what's DEXA?
Oh, DEXA is dual X-ray absorptometry. So it's a low radiation X-ray scan that gives you bone density, positional bone density, basically the scan of your body. So you can see bone density in your legs and your arms and your hips and your spine. Same thing with fat, and same thing with muscle mass.
Okay.
And so this is really important. So just to give you an example, bone density, kind of obvious. If you are on the path to osteopenia or osteoporosis, you want to know that, take steps to address it. Adipose, sometimes we see very lean people who actually have high, what's called visceral adipose. That's the fat around your internal organs. That is what drives, or one of the drivers of metabolic disease. The more visceral fat you have, the higher inflammation, the higher your likelihood of diabetes. But you can look at you might look at somebody and think they look great, but when you do the actual blood work and the DEXA scan, you realize they've got these risk factors. So those are much more actionable and useful biomarkers than an epigenetic age test, and they cost about the same amount. So really, you're much better off doing the stuff that's actually useful.
Okay, we gotta list them up, put them all in a list, and put them in the description here. And so I want to bring it back to what you originally opened with the dogs.
Yeah.
So could you tell me about the dog project?
Sure. So the dog aging project is something that we started in 2014. And it really has 2 goals. One is to understand what are the most important factors that influence aging in dogs. So genetic and environmental factors. These are all, again, in pet dogs living with their owners. So this is not laboratory work. This is dogs in the real world.
Why?
Well, so a couple of reasons. One, I'm a dog person. I personally wouldn't ever do research on dogs in the laboratory. And 2, one of the powerful features of studying dogs living with their owners is that they share the human environment, right?
Okay.
So that's something we can't recapitulate in the laboratory. And of course, another benefit is dogs age 7 to 10 times faster than people do biologically. So we can actually do these studies in a much more reasonable time frame. So the biggest part of the dog aging project is aimed towards that goal number 1. understand what are the most important genetic and environmental factors that influence aging in dogs. That's done through something called a longitudinal study of aging. That just means it's observational and we get data on the dogs over time. So annually we get data on the dogs. The other part of the project, goal number 2, is to do something about aging, right? So that we're addressing through a clinical trial. It's a randomized placebo-controlled veterinary clinical trial of rapamycin to determine, does rapamycin slow aging in dogs? So we have about 200 and some dogs enrolled in that trial right now. Our goal is to get 580 dogs in that trial. And once we hit that enrollment, we will be statistically powered to detect a 9% change in lifespan.
Wow. Okay.
So right now there are 50,000 some dogs participating in the dog aging project. So it's a big project.
Okay. And so does this remain siloed to dogs, or are you going to expand what you learned into humans?
Well, certainly. I mean, I don't know the dog aging project itself as an organization at this point has no reason or expectations to move into human studies. There's enough to do in dogs.
So it's just about the dogs.
And I think much of what we learn in dogs definitely will be relevant in human, and will seed studies that can be carried out in humans. So be hypothesis generating for human aging. Having said that, more than half of Americans who have dogs say that they consider their dog to be part of their family.
Yes.
So I would suggest that there's intrinsic value in being able to improve health span and lifespan in dogs, independent of what it's going to tell us about human aging. It'll tell us a lot about human aging, but it will also be important for improving the quality and quantity of life of the dogs, which is important for the quality of life for the humans.
Right. Who here has dogs? You have a couple dogs. Would you say your dogs are part of the family?
There you go. Exactly. That's
children.
Actually an important point. So in the clinical trial, we treated it just like a pediatric clinical trial when we think about safety, right? Because so many people do consider their dogs to be like their children. Mm-hmm. So one of the things that means is you better be darn sure that you're not going to kill anybody's dog, right?
Yeah, absolutely.
So we were very, very careful leading up to the active trial now to make sure that we had all the safety data lined up before we did anything in dogs.
And why this project?
Why the dog aging project? Yeah, I mean, I think so in many ways, we already talked about some of the reasons why dogs are a good animal in which to study aging, companion dogs in particular, living in the real world. They age faster than humans. They share our environment. We know a lot about the genetic architecture of dogs with purebred and mixed breed, so we can map genes. And people love their dogs, right? Mm-hmm. So all of those things are good reasons to study aging in dogs. For me personally, I'm a dog person, and it was really in 2014 when I had this sort of light bulb moment where I understood completely why studying aging in dogs would be interesting. But I realized, we've got these interventions that slow aging in mice. Some of those are going to work in dogs. And then I was like, oh my God, I could slow aging in my dog. So of course I have to do this, right? So that's really what led me to start, working on the dog aging project.
How many dogs do you have?
So I don't have any now. We lost our German Shepherd about 7 months ago, which was absolutely brutal. At the time we started the dog aging project, I had 2, and my wife and I have always had at least one. This is the first time we've been without a dog. He was a very special dog, and it's going to take us a while to get over losing him.
I see. Are you, are they cryopreserved or anything?
We did not do cryopreservation. I would say, I mean, I understand the rationale and the logic behind cryopreservation. I am pretty convinced that the technology is not there to successfully achieve cryopreservation and the outcome of, eventually coming out of cryopreservation at this point.
Okay. Are your dogs cryopreserved? I mean, are they signed up to be? Well, they're going to live forever with the dog aging project, right?
There you go. Yeah.
Cool. So you have a podcast. Mm-hmm. Is it called the OptiScan podcast?
OptiSpan. OptiSpan.
Okay.
OptiSpan.
And why the name?
Optimal health span. Put
Oh,
them together.
okay. OptiSpan. Love it. And for people listening here, if they want to hear it, where should they
Yeah,
follow
so
you?
it's on YouTube, OptiSpan podcast. I'm also on X and Instagram at mkaeberlein.
Okay. And for all the progress that you're seeing right now in the whole longevity space, what would you say is the biggest breakthrough that's happened recently?
That's a good question. I mean, it's hard to know what's going to ultimately be the biggest breakthrough. So I'd say,
Okay.
one of the things that I am particularly excited about is simply the growth in the enthusiasm and visibility of the field, right?
Yeah.
That I think is going to have long-term impact for sure. We're already starting to see it at the level of policy regulation. Nothing's really happened yet, although we're starting to see things like the expanded right to try law in Montana. I think we'll start to see things at the federal level. So I think that is a momentum shift that is going to have big impacts down the road. That also includes all the doctors, medical professionals who want to get into this space. There's going to be some growing pains to go along with it, but I think I'm really excited about. On the scientific side, I think the one thing people would point to as the most promising intervention right now is epigenetic reprogramming. I think that has the highest ceiling of the interventions that we know about right now. What I mean by that is it has the potential to have very, very large effect size on health span and longevity. So far, there's no data to suggest that it's going to be better than rapamycin. The studies that have been published to date, people can't even do as good as rapamycin in mice. So I think we just have to kind of wait and see how that plays out.
I see.
So I'm I'm very optimistic that we will have what I think many people here would consider modest gains in health span and lifespan available to people who want that. I think everybody should want that, but there's some strange thoughts about longevity out there. I don't know yet how hard it's going to be to achieve large effects on longevity. And just to be clear, I'm all for large effects on longevity. I'm all for radical lifespan extension. Although I was just at the Dublin meeting and somebody who's in the considers themselves to be a radical lifespan extension proponent, asked me first of all about this divide between people who want to promote health span and people who want to promote longer lifespan. And I'm like, there is no divide. That's like made up. I don't know anybody who understands the biology of aging and says, we only want to do health span, we don't want to do lifespan. So I don't think there is any real divide. And then he was like, well, but how do we get people to embrace, radical lifespan extension and not think that we're, a fringe element? And I'm like, well, stop calling yourself radical. I mean, by definition, you're radical. Of course people are going to think you're fringy. So come up with a different word. So I do think there's a messaging piece here.
I see.
But I think the goal is pure and true. And we should all be about increasing the quality period of life by as much as possible. Great. I think we can have differences of opinion about, given the data we have today, how much progress is being made, how close are we to achieving that. I have found myself becoming a little bit more pessimistic in the recent years, simply because when we look at our ability to slow aging in animals, and the best way to quantify that is magnitude of lifespan extension, and the animal we should probably look at is mice, because that's where we've got the most data. The biggest effect on lifespan in mice from a non-genetic intervention was an experiment that was done 30 plus years ago. So if we were really getting closer and closer and closer to longevity escape velocity, shouldn't we be getting better and better and better at increasing lifespan in mice? We're not. So that doesn't mean we won't get there. It doesn't mean that there couldn't be a breakthrough tomorrow. But the data so far, the trajectory is not suggesting to me that we're close to that sort of breakthrough moment.
Why do you think that is?
It's a good question. I think it's a combination of factors. I think certainly the field has been underfunded in terms of resources. So not enough has been done to find new things. I also think the hallmarks of aging had an effect, an unanticipated consequence, that it narrowed the focus of the field to the hallmarks of aging. Meaning all the other stuff we don't understand about aging biology isn't being studied, because in order to get a grant, you almost have to focus it on the hallmarks of aging. So it was an unanticipated narrowing of the field that caused, in a resource constrained environment, that caused limited or very little resources to go to understanding what we don't understand. I think we're going to have to understand that dark matter of longevity before we're going to get big breakthroughs. I might be wrong, but that's my guess. And then the last thing is, it is theoretically possible, and I think there are some reasons to believe this is true, that there's a barrier at around 120 years, the species maximum lifespan. And by barrier, it's not a barrier we can't overcome, but that the approaches needed to get past the species maximum lifespan may be fundamentally different from the things that we're studying now: rapamycin, calorie restriction, insulin signaling. The biology might be different enough that we're going to need different approaches to get past that species maximum lifespan. We haven't made much progress on even understanding what that is. And so it may take a while to figure that piece out. I just don't know how long that's going to take.
I see. And so if you had a magic wand and could change anything about the way things work, tear down a barrier or open the lid, what would that be?
Yeah, I mean, I think the obvious thing would be to allocate resources to aging biology that fit the potential positive outcome for humanity, right? And again, what that means, like, what are the numbers? I could talk about numbers, but I would just say right now, biological age is the greatest risk factor for 9 of the top 10 causes of death in the United States. That's just a fact, okay? And yet, 0.5% of federal spending on biomedical research goes to the biology of aging.
One
half of 1% for the thing that is the single greatest risk factor for 9 of the top 10 causes of death in the United States. Wow. I would argue that aging biology should get at least as much funding as cancer, heart disease, kidney disease, diabetes, go down the list, right?
Yeah.
And so I think that would be the one thing I would change. I absolutely believe if we allocate resources to this problem, we will make big progress.
Fascinating. So is there anything else you'd like to share or talk about here?
No, I guess the one thing I would say is I've had a great time at RadFest. That's my first time here. I've really enjoyed it. I've met so many cool people. We talked a little bit about my frustration with the way some of the information is presented.
Yeah.
But beyond that, I think it's really inspiring and exciting to meet so many people who share the mission vision of, helping as many people as possible live a quality life for as long as possible.
Excellent. And for people who want to see more about what you're working on, what you're doing, keep in touch, how should they?
Sure. So as I mentioned, the company I run now is called OptiSpan. Our website is optispan.life. We have a podcast, the OptiSpan podcast, and I'm on socials at Kaeberlein.
Okay. All right. Well, I appreciate your time, Dr. Matt Kaeberlein. And sorry, Kaeberlein or Kaeberlein? Kaeberlein. All right. I'll re-say that. Appreciate your time, I appreciate your time, Dr. Mark. My bad. Mark, Matt. All right. Well, I appreciate your time, Dr. Matt Kaeberlein. And thanks for coming on the Immortalis podcast.
Thank you.
And thanks for doing your work. It's some great stuff.